Hi, my name is Trevan, and our group will be going over Chapter 8, which is Sampling Distributions. Sampling distributions is defined as the distribution created by repeated sampling from a population. From this, there are two kinds of sampling distribution, and the one that Bryan and I will cover is sampling distribution of the mean. This is defined as the distribution of all the sample means put together. So, another key factor of this chapter to keep in mind is the central limit theorem, which states that the sampling distribution of the mean of a random sample drawn from any population is approximately normal for the sufficiently large sample size. So, Bryan and I will now cover an example how to apply these.
Hi, I'm Bryan, and I'm going to talk about the sampling distribution of the mean and give you an example out of the book. So, first off, we're going to use our fancy CCU SBL fancy leather-bound notebook to go over an example. So, our first example talks about here a cola company, and the foreman of the bottling company observes that his bottles hold 32 ounces right here, as you can see by this line. So 32 ounces with a standard deviation of 0.3, so down here or up here. Now, if he were to sell just one bottle, the probability that the cola bottle would hold exactly 32 ounces is fairly low. Now, as he sells more and more and more bottles, say he sells 1,000,000 bottles, the mean of all the bottles sold is going to become more and more closely related to 32 ounces. This is further represented by the textbook on the graph on page 124. In this first top graph here, it shows that with few bottles sold, there's a very wide range hitting right at 32 ounces. As you sell more bottles, in the second one, say this is 100 bottles, it becomes closer to right where he wants it. And as the more bottles we sell or sample, the closer that sample mean will be.
That is part 1 of Chapter 8, which goes over the sampling distribution of the mean.
Now we're going to pass it over to Cassie and Chase to cover part 2, the sampling distribution of the proportion.
Thanks, Bryan and Trevan. Now we're going to talk about sampling distribution of proportion, which is the estimator of a population proportion of successes in the sample proportion, which we count the numbers of successes in a sample and compute them where P equals the number of successes and divided by the sample size.
So go to the example for 8.2, we have candidate A, which is favored by 0.6 in the purple, and candidate B, which is favored by 0.4 in the red. And this is to simulate an election. So we took a sample of 10 people in our various CCU admissions, politically correct, stick figure representation, and we took that survey. As we moved down one more, we get the results of that survey. The number 1 representing the number of people or which person selected candidate A. You'll notice there are 6 number 1s in that column. Moving down one more square for some definitions, we have binomial distribution is the distribution of the number of successes, as we mentioned with Cassie. And then the sampling distribution of P is a distribution of the proportion of successes. As we go up, here are a couple equations to get us there as far as what we're looking for in this section. The first one is if we just take one sample. The second one is if we're going to take multiple samples. The n is representing the number of samples so that we can divide by that number. As we come down one more square, we're going to see a graph that's similar to what Bryan and Trevan did. So pretty much saying the more samples that we take, the closer we're going to get to the 2 marks that are being represented. In other words, the more samples we take, the closer we're going to get to 0.6 or 0.4. Those are going to be the marks that we're going to end up having with the multitude of samples.
So to wrap up the second part of Chapter 8, we need to know 3 different things. The first one is that we need to know that a binomial random variable can be approximated by a normal distribution. The second thing is that we need to know that a distribution of a sample proportion and its parameters. And then the third thing is that we need to know how to recognize this type of problem and use the normal table to calculate probabilities.